Hello, welcome everybody. I'm here instead of Dirk Michael Wagner because he has an urgent another meeting today with our CEO and he can't be here. So I'll try to give you tell you through a few words about the slides he sent to me. So let's have a quick look at the agenda. First, I'd like to talk about who we are and what we do. Then I'd like to talk about Smart Grid Challenge and show you a few facts. After that, I'd like to explain why we choose OSGi to manage distributed power sources. And in the last 2 points, I'd like to tell you how we implemented it in detail. So here we go. EnBW ODR is a regional utility. We maintain a power grid that is 4,500 square kilometers wide. We have 200,000 customers in electricity and 15,000 customers in gas. We also offer telecommunication services. Our business segments are purchase and sale of gas and electricity. We operate the grid. We are internet service provider because if we dig the ground and throw cables or gas pipelines in there, it's reasonable to also throw fiber cables in there. And we also offer energy-related services to municipality utilities and municipalities. First, I'd like to tell you the area we work in. There are 4 types of power grids in Europe: the maximum voltage grid and the high voltage grid, where big power generations are connected to, and the stuff where we work in. This is the medium voltage and the low voltage grid, where the new energy sources are connected to. So through EnBW, paragraph 11 and 13, German legislation said distribution system owner, these are the guys that operate the grid, are forced to manage all renewable power plants. This means we have to monitor online each power plant, each renewable power plant that has a peak level that is above 100 kilowatts, and we are able to reduce, and we must be able to reduce the power level if the grid states needs it. This we had to do without discrimination. This means we cannot only limit one power plant each time, we have to do it in a discrimination-free way. And to give you a number, there are currently 1.3 million renewable power plants in Germany. Because we are a countrified area, the number of renewable power plants is far above the average in Germany at our region. In 2012, we had a ratio of renewable power plants that was 36%, and in Germany, the average in Germany was 23%. And as you can see, 70% of all buildings in our area had a rooftop PV plant. And as you can see also, in 2012, the maximum peak capacity is 50% above the demand. What we also see is that demand and supply changes over the years. That means in the winter time, the demand, as you can see, is the blue line, and the feed energy is the green line. In the winter time, everything is fine, and in the summer times, we have on sunny days where the wind blows 6 times more generation than demand in our grid. And to give you an outlook, as I already mentioned, 36% renewable energy is currently in our grid, and we expect that it grows up to 90% in 2020. So here we go. Why we choose OSGi-based approach for this challenge? Because we need to control the distributed power plants. We need some sort of gateway to do this. And we choose a cellular-based gateway to do this. And we want to be manufacturer independent. First in hardware and an operating system, and also in maintenance. This means every manufacturer of gateway brings his own software component to manage the gateways. But we don't only want to have one manufacturer. We drive a multiple manufacturer strategy that if one manufacturer has a problem in its device, not all of our systems are affected. And we also want a general way in provisioning these devices. Another point why we choose OSGi is that it's already in use in a wide area. BMW uses it in its entertainment system. It's scalable. It offers standard services like the event manager, the HTTP service, configuration services and stuff like that. There exists a large community and there are many Java developers out there. And this is the setup that we currently drive. As you can see on the left side, for example, this is a biogas plant. There's a generator and some sort of controller for this generator. The red device you can see there is a cellular radio router with a smart card support we already installed. And our transport mechanism is Modbus TCP and RTU because it's a protocol that is widely used in automation and it's quite easy and simple. Then we use a VPN to communicate with our backend system. In our backend system, we have the processed NPRM remote manager, where we connect the OSGi devices and manage them. It's quite sexy because it's also based on OSGi, and we can extend it with our functionalities we need without a big deal. And we also can run the protocols that we run on the gateway also in the backend to connect several systems to it. Yeah, we have a software repository running there. We also have a bunch of other systems that communicate using processed NPRM common ways to talk to it, like REST and SOAP interfaces. And as I already mentioned, we have a bunch of protocols that we developed to enable our control center and our power management staff to talk to the gateways in a transparent way. And as I already mentioned, that we offer services for municipality utilities. We're able to connect multiple control centers and power management systems and show them a part of the gateways out there and allow them to control them. This picture shows the architecture that we use in the gateway. On base, most of the routers come with a Linux, but we have different processor architectures. We use Intel, we use ARM, and we also use Freescale PowerPC. Most of them run Linux. Most of them also run JVM, GNU ClassPath, and Equinox. It's not mentioned here, but it should be there. Then we have a bunch of native code out there, RxTX libraries, inverter protocols that we receive in the binary format. And most of the gateway manufacturers also offer a more or less native API to get stuff from the gateway or to configure the gateway. On top of the OSGi runtime, of course, we use core services like HTTP, config services. We also use the NPRM messaging service, but we access the smart card to do TLS tunneling. We also have a bundle running that allows the operator of the power plant to configure, for example, its Modbus registers or ENSO SIM pins or stuff like that. Then we have protocol packages running like Modbus and other ones. And we have the Power Manager bundle running. And the Power Manager bundle uses the process control unit stuff to abstract power plants and generators and transparently make them accessible from the back end. We also have optional packages a customer can order. One of them is power generator monitoring. This means we monitor the generators of the power plant, and if for whatever reason the generator goes down or stuff like that, we notify the operator. We also have control energy marketing packages out there. This means that we sell energy or we fill, for example, the gas buffer of a biogas plant in some situations and empty it afterwards. Oh yeah, of course we also have specific automation protocols. This means if the controller of a generator does not speak Modbus native, we also offer different protocols, but this have to be ordered on extra by the operator, and of course have to be paid on extra. And we also have the option to install folder packages. This is the backend infrastructure that we use. On the left side, you can see we run an NPRM backend server, also with the core services. There we installed a power manager that registers services for every control unit on every gateway with specific properties in the service registry, so that protocol adapters can filter the registry and talk to a service and don't need any information about the gateway or stuff like that. It just addresses, or it just grabs the service with a specific address property and talks to it, and the rest goes very transparent for the application. Yeah, we also have protocol packages here. For example, IEC 104. It's a common protocol for utilities. Our control center, for example, talks just one EC 104. The power management also uses the NPRM SOAP and REST API to trigger operations and schedule stuff on the control units. And of course, our other systems like SAP and stuff uses the SOAP and REST API to talk to the gateways and the NPRM, of course. So let's go a little more in detail about the registry-based addressing using control units. We found it very, very sexy to use this approach, because addressing is just asking the registry for a specific service with specific properties. For example, if a EAC connector registers IEC 104 power plant service for each gateway or control unit, it uses the IEC 104 address property to register the service. The IEC 104 protocol package creates a slave instance and waits for master connections. As soon as the master connects to the service, it also registers a 104 master service. And then we're ready to go. If a message from the power plant goes up, it just looks for all master services and forwards this message to them. The other way around, if a master wants to address a specific power plant or generator, it uses the address to ask the registry for the specific service and talks to this service. The benefits we see from this approach is that different protocols are able to talk native to the same way, a gateway, power plant, with minimal extra effort. You just have to register as the registry. And it's also transparent for all different protocols. If you talk Modbus to the gateways, or if you talk IEC 104, every protocol sees the changes transparent. Control units are also very sexy because you can use or work on them without any extra development effort. You can trigger an operation, for example, tomorrow at 13, and afterwards you can check on specific amount of gateways, and afterwards you can check if the operation was successfully executed, how many gateways executed it with a failure, how many gateways are pending. Yeah. You can also use control units with NPRM procedures and scripts without any extra effort. And what also is very sexy, that is, you can use a single application firewall to make your application safe. This means if you have different protocols like IEC 104 or Modbus, you have to implement the rules in the specific protocol way. But we only have to implement the firewall rules or application firewall rules on base of the control unit level. So we can check if the maximum power that the generator provides us is above, or at least at the level that is maximum for this generator. That's it from my side. If you have any questions, please feel free to ask. Yep.
So you were talking about PV on the homes, but the gateway is only used for sources that generate over 100 kilowatt, or?
Yeah, it's only used for plants that have more than 100 kilowatts, but we also have a component that can be run on the system, on our smart home system, that does exactly the same thing for components that are below 100 kilowatts.
Okay, and the smart home system is a different
Yep.
Technology.
It's not a different technology, it's OSGi, and it's more or less the same bundle, but this is the first thing we're out in the field because we're forced by legislation to do this. And to do it on plants that have less power than 100 kilowatts is optional.
Can you give us some examples of what you typically do while monitoring? Does that include switching on and off, or more detailed instructions on, I don't know what?
I don't get you right.
So you, in your talk, you said like legislation requires
Yeah.
us to monitor those installations.
Oh.
So what does monitoring mean? Is that just keeping an eye on? Is it still running, or do you?
No, monitor means that we have to monitor the actual power of the generators.
Okay, so it's not sending out commands?
No.
How do you get the data? I mean, you base your decisions on the data of supply and demand. Is this the supply and demand on your own network, or is this on the whole region and combined data from other network operators as well? Is there some kind of central entity that manages this?
It's a kind of hierarchy, you know. We're connected to a higher level grid, to a high voltage grid, and we, if they recognize that they run into a problem tomorrow, they trigger us, and we had to help them to not run in that problem.
So they give you some target number actually.
Yeah.
It's a day ahead forecast.
Yeah.
Okay. And is this standard? Are these standard interfaces, or is this kind of on regional levels? Is this decided?
At the moment, it's based on email.
Okay. Well, that looks like standard protocol.
Any more questions?
The rules, how are they based? Or essentially, I didn't get if the rules are in the gateway for the plant, for each photovoltaic or whatever, or it's communicated some data to the server and the server processes the rules.
Yeah, it's communicated to the server.
So nothing is independently in each gateway.
No.
It's very much simple than there.
Yep. Yeah.
So is there a way to get updates like binaries or OSGi modules pushed down to the gateway?
Yeah, the NPRM offers this functionality, and we just select the gateways and fire.
Is this an open source project?
No, it's a commercial product from Process.
Which is the data rate from the gateways?
Pardon?
Data rate. How much data comes from the gateway?
Oh, I can tell you that in detail, but we just
Every minute?
no, we just update the values if a certain level is reached. If it differs to the first value, maybe if you actually have a generator value of 500 kilowatts, we just update the value in the backend if it's above 520 and below 480, for example.
So so the it's not much traffic influx.
No.
For monitoring, okay.
And how do you do this with photovoltaic? If, for example, I have an installation of 10 kilowatts on my house.
Yeah.
I mean, how do you can't actually regulate this, or do you actually?
Yes.
Are you capable to disable particular strings or anything, or what?
Yeah, most inverters are capable.
What happens to the energy that actually comes out of because these are photovoltaic cells, so the energy still comes out. It's still generated.
I have no idea, but
So they just radiate it out again. Okay.
Heat up or send it somewhere else.
Yeah.
Is there a reason why you use Equinox in the gateways and not the
Yeah, it's a reason because we asked the manufacturers of the gateway to come up with a running OSGi on their system. Most of them decided to use Equinox, and
is it planned to use concierge?
we tend to use concierge, but yeah, we have to talk to the manufacturers.
Any more questions? No? Okay, well, thank you very much.
Yeah.